Yesterday you had the video on adding and subtracting for your inverse operation when it was dealing with inequalities. Today we're going to focus on multiplication and division of inequalities. And some people might have wondered, why is it that we separated addition, subtraction, multiplication, and division? It's because multiplication and division for inequalities, when solving them, even though the process for solving them is exactly the same as it was for equations, there's just one minor rule that you have to make sure you follow. One little tiny exception, and that's when you're multiplying or dividing by a negative. So let's go ahead and make a clear-cut idea that we've got a major rule that needs to be followed. If you multiply or divide by, and that's really important that it's multiplying or dividing by a negative. So if you've got a negative coefficient or a negative divisor, and you're going to have to multiply by that negative or divide by that negative when you're solving, then the inequality symbol will reverse or flip. Now, reversing is different than rewriting. Having to rewrite an inequality because the x isn't on the correct side is different than having to flip it because of multiplication or division of negatives. Okay? So all we can do in this situation is just a few practice problems so that you can see what I mean by that. So if we have the problem 3x is greater than or equal to negative 18. We have a negative value here, but is our multiplication and division a negative? No. This multiplication is a positive, isn't it? So that means because of the fact that we are going to, for our inverse operation, we're going to be dividing by a positive 3. Because of the fact that it's a positive 3 that we're going to be dealing with, we're going to go ahead and keep the inequality. So when it's multiplication and division involved, your question is to ask yourself, after you've multiplied or divided, do you keep it or do you flip it? So in this case, we're keeping it because it is a positive 3 that we're dealing with. And we divide both sides by 3, we're going to get that x is greater than or equal to negative 6. Now, I'm not going to focus on graphing right now. However, if I were to be graphing it, is that open or closed? It's going to be closed because it's got the equal sign under it. It's closed. And is it going to go left or right? Right. Because it's pointing to the right. So we know it's a closed circle, goes to the right. Okay, if I've got 2 is greater than x over negative 7. 2 is greater than x over negative 7. The first thing that I need to make sure I do before I even start solving is what? Chris? Flip it, right? We got to rewrite it. We have to do a rewrite. Yes, Bryant? Because it's multiplication. Yeah, still have to solve it. Okay, so before we start solving, we need to do a rewrite because the variable's not on the correct side. We want the variable on the left. So we're going to flip everything. So that means this is now going to become x over negative 7 is less than, so the inequality flipped, less than 2. Nothing else has changed. I've just basically, it's almost as if I'm picking it up and flipping it over. Flipping the whole thing over, okay? So I've done my rewrite. Now, What am I going to do to solve this? Julie and David. It's not addition. What operation is it when it's... So this is division right now, isn't it? Multiplication. So we're going to multiply. We're going to multiply by -7. Now, because of the fact that I'm going to multiply by a negative, am I going to keep or flip the inequality? What happens when we multiply by negatives? Look up at the rule. If we multiply by a negative, then you're going to flip the inequality. Just the inequality symbol, not the whole statement. So we're going to flip the symbol. Because we're multiplying by a negative, we're going to flip the symbol. So that means that it's no longer going to be a less than sign. If I flip it, what is it going to become? Greater than. This is going to become a greater than sign. I'm going to flip it, and then I'm just going to solve it like normal. Multiply both sides by -7. That's going to give me x is greater than, what's 2 times -7? -14. And that's it. I'm done. Open circle goes to the right. So that's the thing that is the tricky part. You have to remember that rule, that if you're multiplying or dividing by a negative, you've got to flip the inequality. Just the symbol, not the whole statement. Yes. Yep. If it's a negative, yeah. All right, if we've got -5x is greater than -15. Do I need to rewrite? No. What operation is my inverse? Division. What am I dividing by? -5. Am I going to keep or flip? Flip. Dividing by negative, I'm going to flip. So this, my inequality symbol is going to flip. It's going to become less than. So instead of greater than, it becomes less than. So we're going to divide both sides by -5. What's -15 divided by -5? 3. +3. -21 is less than or equal to 3x. Do I need to rewrite? Yes. So when I do the rewrite, it becomes 3x greater than or equal to -21. What's the inverse? Division. So we're going to divide by what? +3. I'm dividing by a +3. So positive, am I going to keep or flip? Keep. So that greater than or equal to sign stays a greater than or equal to sign. And what is x going to be greater than or equal to? -7. Good. That's it. You always rewrite if the variable is not on the correct side, and you always flip if you're multiplying or dividing by a negative, only by a negative. 3 is the positive. Even though 21's negative, we're dividing by a +3. So basically, look at what's attached to the x. If what's attached to the x is a negative, you're going to wind up flipping it. Because if your coefficient is a negative, or if your divisor is a negative, that's going to cause you to have to flip it. And the reason for that, so let me show you a quick reason as to why. If I tell you -4 is less than 3, is that true? Is -4 less than 3? Yes. -4 is less than 3. That's true. Now, if I go ahead and I multiply this by 2, both sides by 2, that's going to give me -8 and 6. Is -8 still less than 6? Yes. Okay, so now let's take that -4 and that +3, and this time, oh, actually, we'll change it because I want to work with an even number. So we'll say -4 and +6. It's still less than. Let's say I divide by a -2 on both sides. -4 divided by -2 becomes a +2, and 6 divided by a -2 becomes a -3. Is 2 less than -3? No. So by dividing by a negative, it reverses the truth of the statement. Okay, so that's why this is no longer true. It has to become greater than. That's true for division and multiplication of positives and negatives. Okay, so positives keeps it the same. Negative is what reverses it, but only for multiplication and division. Okay, all right. You're going to be going on to IXL. You are going into your 7th grade standards on IXL. So please, some of you have been going into 8th grade. I don't know why. Go into 7th grade, and you're going to complete T4 this time. T4, and I want an 80%. I want 80% accuracy on T4. If you have not finished T1, T2, or T3 to the 70% requirement, that needs to be done by tonight, midnight. Tonight at midnight is the cutoff. So if you didn't finish it, so let's say you finished T4 in class right now, but you didn't finish the others, finish them in class. Is that clear?